Okay, should we continue? I think most of you are back, right? Are you good? Okay. Okay. So we have our first service up, right? So next step was to pick a second one. And for the second service to implement, I decided to go with one of the ugliest ones, the ones that have database. So I decided to go with users. So users will have its own database. This is the summary. The black endpoints are the ones that existed in the original application. So you could get a list of users, and that was open to anyone. So you could get the list of connected users without logging in. So you will see the bar on the right. It'll show who's chatting before you log in. So that didn't take off. And then you could send a token to get the list if you have a token. So after you log in, then you do send the token, and the token in that case is used to mark your user as active. So if it's online, then it'll show up on that bar on the right. You could log in by sending a post request that will create the new user. And you could modify the user, like rename it, by sending a token, that required a token. So all these are either token optional, token, but because I decided to put the token service separately, right? I initially decided to divide by family of URLs, right? Consider the problem where the UI needs to register a new user and get a token. So you send a request to the user service, and basically that registers the new user. And then you send a request to the token service to get the token, and the token service will receive a username and password and needs to validate that before giving out a token. But the token service doesn't have access to the user database, right? So probably, a decent design will be to have users and tokens in the same service. I decided to do it this way because I think it's a good example of two services working together to get something done. Okay. So the way this is going to work is the token service will get a token request with username and password, and it'll have to ask the user's service to verify those credentials before it gives out the token. So the way that's going to happen is in the user service, we're going to have a new endpoint that's specifically made for that. Any other service that needs to verify credentials will use the red one. So it'll be /API/users/me. Basically, it returns information about a user. It takes basic auth, so username and password. And if those are valid, then the user service will return the user information. If those are invalid, it'll say for one. Okay, so that's the token service, which we haven't deployed yet, will use this. But I was thinking ahead and decided to add this new endpoint. So as far as structure, it's very much like the UI service that I showed you before the break, except that this one's longer because it's got database models, right? So we're using Flask, SQL Alchemy, the usual stuff, the same thing that I always do. For the endpoints that take tokens, it's going to import the token validation from the common package. And then just to show you how this will work if you have database migrations. I added Flask Migrate, which I didn't use last year on the monolithic version of this app. This time I decided to put it there just so that you realize that you're going to have migrations for users and you're going to have migrations for messages later on when we add that service. And they're going to have completely separate histories, right? They will upgrade on their own timelines independently of each other. This mfrun script that I showed you that bootstraps a new instance of a service, that script, which is in Bash again, it knows services that need a database. There's environment variables that declare or define which services need databases. So if you're starting a service that needs a database, it'll go look and talk to MySQL with an admin password and create the database if it doesn't exist yet. So we want to make it super easy to bootstrap a new service. So I don't want to have to remember when I start a service, if it needs a database, I don't want to remember to have to go create the database. So mfrun will do it for us. The service itself cannot create the database, by the way, because the service will not have admin access to MySQL. That's very important, right? You don't want, the user that you use for MySQL in your service to be an admin. You want to give only permissions to modify its own database. So this needs to be done outside and before you start the service. The service itself, when it starts, it can do the migrations, and it does. But the database creation needs to happen outside with an admin password to MySQL. So that's users here. Once again, this is a pretty standard, I'm going to look at V1, pretty standard app in Flask terms. It imports the authentication stuff from the common package. There are some utilities that I also put in the common package because they're used in all the services. The basic auth, so checking for username and password, that's not a common, it doesn't belong in common because the only service that can check a password is this one. So that's here. So this is a guide. This is using the Flask HTTP auth extension. And right here you can see that this is how it's done. It's pretty standard. So this is copy pasted from the application, from last year. So we have the model, standard SQL Alchemy stuff. We have, these are these two, the from dict and to dict. These are the ones that convert a model to a representation for the API. So here there's one interesting aspect. There's something that we lose by going to this structure with microservices. Typically you use URL4 to build URLs, and in the original app from last year, I used URL4 to generate the links. So basically, this will be the hypermedia portion of the REST API. You will use URL4 to build links, right? So if you get a user, you will get a link to get the user messages. Well, turns out now the user messages are in a different service, so URL4 doesn't know nothing about it, right? So you can't use URL4, unfortunately, to build URLs, at least not all of them. So there's two options. You can say, okay, I'm going to forget about hypermedia. Nobody cares anyway, right? That's one option. And then the other option is that you build the links by hand. Unfortunately, so to keep things compatible, since the previous version had hypermedia links, I decided to keep them. So those links are built like that, right? Because it's a different service. In a very, if you have a very big distributed service, you could have a service that knows how to build URLs. That will be one way, right? And then services can register their endpoints with this one service that knows how to build URLs. You could do that, for example. So this one and also the tokens one, right? Those are going to be built by hand in this service. By doing this, I saved myself from having to hard code the URLs in the UI. I didn't want to change the UI, so that's basically that's the reason I decided to go this way. But it's not ideal. It's a problem. It's one of the cons, I guess, where you go to a system built this way. Other than that, this is a pretty standard Flask application. To save time during the break, I built the container. That takes a minute or so. So I built it. So to do it, you will go to Flask users in the VM. You will do get checkout 1, which I did already, and then you will do build.sh, which I did already, and that's why it's fast. And then you will say mfrun users. And that's going to run one of the users service. The database will be created at the time you run it for the first time, and then you will have users running. There you go. And this is V1 of the user service. Any questions? So if you were to look at, if you run the application in the browser, now you're going to see that /API/users does not return a 404 anymore, but /API/messages, which the UI will also try to invoke, will, because we don't have that yet. And tokens if you try to log in as well. Okay, so now if I wanted to use the user service, I need to be able to give out tokens. So I decided that would be the next service to deploy. And little by little, we're growing this back into the original application, but implemented in this format. So for tokens, there was 2 things you can do. You can get a token, and then you can revoke a token. This is in the original app. I decided at the time I was about to do this. I didn't know exactly how I would do the revocation part, so I decided to put that off. So I know I need to do it, but I want to see something going first, and then think about what's the best way to do it. So I didn't implement that yet in V1. So this one then has only one endpoint, /API tokens. You send the post request with username and password, and then you get back a token. That's it. To verify the username and password, as I said, tokens sends a request to the user service. So let's take a look how this is the first time we have 2 services communicating. So let's take a look at that. So this is going to be in tokens. Tokens is a very short service also, because it's got only one, that one endpoint. So the basic auth is this is the way we are going to receive username and password, and the way we verify it is by sending a request to API users me. And we send the auth, we pass it through to the user's service. And if that comes back with anything that is not a 200, we say no. And if we get a success, we basically take the content of that request, the response, which is going to be information about the user, and we put it in the G for Flask, so that the endpoint can have access to it. Does that make sense? Now, note that here I'm using a relative URL. So you may think that this requests is requests, but it's not. I have a wrapper for requests that I called originally requests. This is coming from the common package. So this is the module. There's a module called requests that uses the same interface as the Python requests. But it has a couple of added features that are specific to this project. If you send a relative URL, like this one, slash something, without sending a host name or a port, then it'll assume that you're talking to yourself, to the load balancer, so something that's load balanced in the same system. So it'll prepend the load balancer address, which is in an environment variable. As we said, we configure everything in an environment variable. mfrun, when it starts a container, it will set the LB environment variable to point to HAProxy, and all services have it. So you can be sure that that's available to you. So the request module in the common package will do that if you don't send a host name. The second thing that it will do is it will configure requests to do retries. I mentioned that that's very important. Sometimes there are glitches, things happen when you have so many pieces moving, there are sometimes unavoidable, little downtimes. When things upgrade, for example, sometimes you have a very short interruption. So this, the retries, you don't even need to ask for them. You get retries. I'm not going to show you the implementation. The implementation is very simple. You can go look it up in the common package. I want to save time to show you more interesting stuff. If not, we're not going to have time. But if you have questions later, please ask me anytime. I'll be happy to explain anything you don't understand. So, and then the endpoint, basically, this invokes the auth part that's above. And this is a post request that it's going to invoke generate token, which is also in the common package. And this is the function that generates a JWT token. And the contents of the token is going to be the user ID, which we already have in G after we passed authentication. Does that make sense? And that's it. We have another service. That's all it takes. So to deploy this, it's once again, and I also did this one to save time. So you're going to do git checkout 1, build, and then mfrun tokens. And at any time, you can run more than one, as you saw before. If you run 2, it's totally fine. Then you have double the bandwidth for that service. So there you go, tokens. So now we have the UI, users, tokens. We're still lacking messages. So now that's the next obvious move, is to add messages. So messages is going to be in many ways similar to users in that it uses a database as well. This is the summary from the original service. All the messages endpoints are here. And for this one, I found no reason not to implement exactly the same APIs, the same endpoints. So straight copy-paste of all of them from the big app into a small standalone Flask application. I think I didn't repeat this enough. For all these services, when I'm doing copy-paste, in every single one, I made mistakes. Every one. And I found those right away by running the tests. So you need tests. You need them before you attempt this. If you add them after, then it's kind of it's a dirty setup. You're gonna be you're gonna be predisposed to be nice how you write your test. You need to make sure that you have good test coverage for the original code before you migrate it, if you want to be successful. If not, you're going to miss stuff. Another thing I can tell you, I typically, in terms of test coverage, for things that I want to make sure that I don't break, like my public open source packages, I try to go 100%, so test everything. I think 80% coverage is usually good. The corner cases are what's left, so you're probably okay with 80%. For this example, last year I think I had about 80% coverage. and I try to keep 80% on all the services if you run the tests. So same structure as the user service, right? It's a service with a database. It's pretty much copy-paste of the big application. This service had some asynchronous action, right? I don't know if you remember, I showed you at the beginning that a message that you type could have markdown and it could have links. And both things they need some processing, right? The markdown needs to be rendered into HTML. And if you type any links, we went and grabbed the page and then scraped the title and description to show as an extra thing. So those were done asynchronously. That was the task of the Celery worker, if you remember from last year. Unfortunately, Celery is not a good match for this. And I explained this. The Flask service and Celery both run the same code. So if you change one, you're forced to change the other. And we're against coupled services now. We want to have the freedom to scale or upgrade services independently. So Celery promotes a coupled situation that it's not really beneficial. So I'm not going to use Celery anymore. Once again, I said this is too complicated, so I'm going to pass on this. I'm going to go back to synchronous in the beginning. I'm going to start small, just make it be slow, inefficient, but make it work, and then I'll look into how can I improve it and make it go back to asynchronous. So in the beginning, when you send a request to the post request to post a new message, it's going to be rendered right there. I'm not sure there is much new stuff to show in this service, in version 1 at least. Basically, this is in the model, this is when you create a new message. So here, this is the rendering, which I, after I copy-pasted the code from the original Flask, I had to put this back into asynchronous. The method expand links existed from before, but it was called from the Celery side. So I'm calling it here. The render markdown, this is the other one, the one that renders. This is called anytime there's an event handler on the SQL Alchemy column. When you set the message text, that invokes a handler that renders the markdown, and I kept that. Other than that, this is once again Flask standard stuff. So I'm going to go ahead and once again, this is all boring. I'm going to do it again. Build, which is fast because I pre-generated it, and then mfrun messages. So now this is running. Now we have all the components that we need for a first version that's everything. So I'm going to refresh, make sure I get the latest. I don't get any cached stuff, and well, we have it. If I type a link, clunky, slow, but it works. So now we need to find a replacement for Celery, right? You could use Celery if you wanted. You can consider the messages service plus its Celery workers, like one thing if you want. That will be acceptable. I think it's going to complicate upgrades and deployment, right? Because you will have to upgrade both. If you change the database, for example, which both will have to use, you have to upgrade both at the same time. I think it's doable because it's a contained problem, small, There's only two little things looking at that database. I decided to not go that route. So something that people, for some reason in the Python world, don't like is threads. They think they're bad, ugly, never use in Python. We're better than that. I kind of disagree with that. I think threads have a very useful purpose. So what I'm going to do is to do all this rendering in a background thread. So it's going to be an asynchronous request. When you send a post request to create a message, the route, the method that handles that route will start a thread, and then it'll say, okay, fine, 202. So I'm going to work on it. But basically, that's the code to say, I got this, but I'm not done. I'm going to do it on my own time. So it's going to respond with 202, and then start a thread that will do the work. In some cases, you may not want this asynchronous work to be in the same space as your API process. So you may want it somewhere else, so that it cannot affect the performance of your API listening. The part of the service that listens to requests. In that case, you can use multiprocessing. Just put it in a separate process, short-lived process. Or you can go all the way async. I mean, you can go if you're willing to drop Flask, you can go async IO if you want, or you can use any of the other async frameworks that Flask supports, like Eventlet or gEvent. Those are all good options, and it depends on the case which option you should go. So I'm going to use this opportunity to show you how you would work on a new feature on your local laptop and test it, without getting crazy with all this other stuff, the load balancer, all that stuff that you need to deal with. So I'm going to show you how to install the version 2 of Messages, which is the one that starts the background thread on your local laptop, and then you can test it locally by sending requests directly, so in isolation, right? So this is an independent service, so you should be able to test it by sending requests with curl or HTTP or Postman, whatever you use. Yeah, that should work. Oftentimes, you may also want to test it integrated with the rest of the system. So I'm going to show you how to hook up something running your laptop to the load balancer running inside the VM. I'm sure you can guess how, because I showed you already how to do the big FLAC, right, the old FLAC. So it's going to be exactly like that. So I'm going to exit the VM. Now I'm on my laptop. Only have the admin package. So I'm going to clone I need the common package, and I need messages. So in admin, there is this mf bars. This contains a bunch of useful environment variables that configure a lot of things so that you can work with this system. So I'm going to source that. I can show you quickly. So it configures the name of the services. So mfrun uses this to know, what's going on, which services you're using. It also configures which services need a database. Also, mfrun uses this. Which services are dependencies. It configures the pip so that you can pip install things from your local machine. And it also sets this Flask app so that I don't have to think about it. I can say Flask run, and it works. And I said, oh, I forgot to set the variable. So I never forget this way. So a bunch of things that basically configure the environment. So that's sourced. So now I can go in the common package, and I can say make will all. So this make will, by default, it will build the code that you have right there in your directory. If you say all, it will go look in the Git history, all the releases by looking at tags. So in this case, for this project, I had 3 versions. There's 0.1, 0.2, 1.3. So if you say all, it'll build all of them. And then all the versions will go in the folder, in this directory where you have all the wheels. And services may use one or the other, and eventually you probably tend to upgrade all of them to newer versions. But you may have some services that use an older version, and that's fine because we're building all the versions. So this is going to go find all the tags and build all of them. And it knows where to put them because that's one of the variables in mfvars. That's the wheelhouse variable. It's actually it's a sister directory to this one. So now we have wheels and we have three packages there ready to be installed with pip. Pip, if I say pip install this, it'll work because the environment variable configures this directory as a source for packages. So it's pretty handy. So now I can go to messages. I can do the standard stuff, make a virtual environment. I can activate, pip install requirements, usual stuff. And then after this, I can just run it. It's Flask. For me, it's very important to not alter, at least not much, the development workflow that we all love, right? I mean, that's part of what makes me like Flask so much. This is actually very convenient. So now I can say Flask run. And it's running. So this is running in isolation. I can send requests to this at localhost 5000, and I can test the hell out of it. It's just fine for testing. Okay? So I went through this, and first part of this, right? So we are at a point where we can test this locally. I think I forgot. Yeah, actually, I forgot to set version 2 here. We deployed 1, now we're going to do 2. So I'm going to switch to 2 and run version 2. Now, if you wanted to test this, for real, in interaction with all the remaining services, we can write entries in the service registry, once again, to point back to this guy running in the laptop. It's totally fine. I wrote a script that automates that, makes it very easy. It's called mfdev. There you go. So mfdev will write the entries in the registry. So if you say mfdev start messages, it'll do that. Now, before you do that, there's a bunch of environment variables that you need the service to know. So for example, you're going to send tokens to this service running in your laptop, and this service needs to know the signing key for those JWTs so that it can validate them. Right? So all those things are in the VM, in this Vagrant VM right now. So I created another script. It's called mfenv that dumps. Of course, this, it goes without saying, you're going to do this only for development, right? You're not going to play with passwords, so happily in a production server. Never do this in a production server, right? This is for testing only. But mfenv will dump all those, variables that a service needs to the console. And then you can copy paste them and put them in a .env file. So let's do that. So I'm going to go back to admin. You can do vagrant SSH and put the command right there. So you can say mfenv. So it's going to go in the VM, run this, and then out. Please, there you go. So this is a bunch of things. You can see that there's how to find the service registry. It's this variable. How to find Redis. How to find the load balancer. The user session key. The JWT signing key. And then the database URLs for all the services that use databases. You will have to uncomment the one that you want to use if you want to use it. So this is all here, so I'm going to copy all this stuff, take it to messages, and create an end file, .env file, with all of that. So for databases, I can uncomment this one for messages, and then I will be connecting from my laptop into the MySQL database that's running in the VM, or I can opt to not put it and just let the service create the database on its own. So this service that's only for development will be running a SQLite database by default. That's the default. It'll be in your laptop, a file, and that will be the case if you make changes to the database. In that case, you will not be able to use the database in the service without upgrading it, and if you upgrade it, it may cause trouble to the added instances that you have there. So those are all options. So now I can say, now I have the environment, so I can say mfdev. I don't have it in the path here, so I have to go reach into the bin directory of the admin repository. Start messages. Before I apply that, I'm going to switch here. So it says OK, and it reminds me that I need some variables, right? And then it tells me, and this is a default, that there are arguments to mfdev if you want to change the port, all that you can do. But by default, it'll assume that it's your laptop at 5,000. So that there's the new entry. It just wrote the new entry. So now I'm going to say Flask run. And look what happens. Green. Okay? Oh, look at that. I forgot to create the database. Sorry about that. So this is telling me there's no database. So I need to say Flask db upgrade. Because I'm not using the database in the VM now. I didn't configure that. I need a database here. This is going to look for a SQLite database. So upgrade database. Oh, sorry. And now run. And now it should be OK. And it should start receiving traffic. There you go. Now, you see that there's another one, right? So these two are both receiving traffic. But mfdev registers this entry with a weight of 256. So HAProxy can give different weights to different instances. So mfdev, you can look how I'm doing it. It's basically writing the address of the service with an extra weight argument. And that will make it much more likely to get traffic. If this is inconvenient, if you want to make sure that you only get traffic on your laptop, then you can kill the container, the other container, and that will be, that will make you 100% the owner of this service when you test. So basically, that's the development workflow. As you see, it doesn't change much from what you normally do, and I think that was, for me, that's very important. Any questions about this? So I'm going to skip showing you the thread stuff because it doesn't really add much to I think the topic of this class. So you're welcome to review that. But we can deploy that now for real. So I can say here mfdev stop messages. That will remove that dev entry once I'm done testing. And then I can go back into the VM. And messages, I'm going to check out version, this is version 2. I need to build it. It's going to take a little bit. And then once it builds, I can go ahead and run it. And it's going to be interesting because now we can't just run it, right? We need to upgrade. We have an existing version of this. We have version 1 already running, and we are going to upgrade it to version 2. So let's wait for that finish and try that. Right. almost there. So this MF upgrade script, the bash script that does the rolling updates, I created a different, I showed you earlier that you can say MF upgrade roll, and then it goes through the motions of starting one, killing one, starting another one, killing another one, and so on. So that's one way to do it. If you're courageous and you're sure that the new version will be great, then you can go ahead and do that. Sometimes you're not so sure. So another modality that I put in this MF upgrade script is to do a little test. And this by having everything load balanced, all these, the creative ways to start services, they're made possible because the load balancer makes all of this super easy. I'm going to say MF upgrade try messages. So what this is going to do is it's going to start the V2, and it's going to start showing me logs. These are logs specific to this service. You can see now we have V1 and V2. They're running, and these are receiving 50% each of the traffic right now. So you can start looking at this. If you see any problems, then you can immediately Control-C this and say MF upgrade abort. And what this is going to do is just kill V2. And you're done. Safe. Okay? Now, on the other side, if you're seeing that it's looking good, then you can say MF upgrade roll. You don't even need to say which service because there's a pending upgrade. The script knows. It saves a file with all that information. If you say MF upgrade roll, it's going to continue that rolling upgrade motions that I showed you before. So it knows that there's already one that started, so it's going to do the rest after you confirm that the service is running well. In this case, we had only one, so all it needs to do now is kill the V1. So all this happened while the service was running, so it was responsive to all clients. Any questions about this? I'm not sure if you're all asleep, or I'm so great that you understand everything, and yeah, there are absolutely no questions. I'd like to believe that. So, okay, we have 20 minutes. So the next thing that I did was to implement the token revocation. So for that, remember I told you that it was highly inconvenient to have services verify tokens with a token service, and that's why we migrated to JWTs. Okay, there's a problem. The problem with JWTs is that you don't have to talk to the token service to verify them. So if they're revoked, how do you know? You're not talking to anyone. And if a token is revoked, you somehow need to know. So the solution for that is, unfortunately, to create a database not of tokens, but of only revoked tokens. And the logic that you need to convince yourself that this is not as bad, because looking up a revoked token is going to be much faster than looking up all the tokens every single time, right? The revoked tokens are going to be a small percentage of all the tokens, so this database is going to be small. In addition to that, tokens expire. JWTs have an expiration, so you need to keep them on the revoked token database only until they expire, and then they can go away. So your revoked token database is going to be typically small, and doing searches on that database, it's going to be much faster. And maybe you can allow yourself to cache those searches if you are not paranoid, if you don't mind maybe caching a revoked token check for 1 minute, for example. So if you get queries about the same token during a period of 1 minute, you can use cached information. And then if the token gets revoked within that minute, you'll find out in a minute. So you can do all those things to minimize the toll on all these requests inter-service for authentication related purposes. So we had the post request to request the token, and now we need to check if a token is revoked or not. That's going to be a GET request and the same endpoint, so API tokens. And then we need a way to revoke a token, and that's we had that in the original app. This is the one that I didn't implement in the first release of tokens. So that's going to be the delete request, and you pass the token in the headers of the request. So we need to implement these two. So what I'm going to show you, I think the only interesting thing about this, in version 2, actually I'm going to show you the diff. So this is version 2. So we added the endpoint to revoke the token, right? And all this is doing is just writing the revoke token in a database. And what did I do here? Instead of creating a MySQL database for this, since this is you want this to be super quick, right? You don't want all the weight of a full MySQL database. All you need is to find this entry, see if it's in that list or not. In addition, as I said before, these entries have an expiration associated with them. You want to keep them only while the token is valid, but then you want to remove them. So the etcd, the service registry that we're using, has the ability to store things with an expiration. So I said, well, okay, I could use a different portion. On that hierarchical structure, we have /services for the service registry. Let's use /revoke tokens to hold a list of revoked tokens. That's what I did. I used this Python etcd client library, the same one that I'm using to do the registration in the common package. And any token that gets revoked, I write it to that place in etcd, and I extract the TTL. This is the time to live, the expiration, when it expires. So I get the expiration from the token. If you recall, when we get a token and it passes validation, we put it on the G variable. So from there, I can get the expiration. This is part of the standard. All JWTs have, well, actually, if your token expires, then you should have an EXP item in the claims portion of your token. So I look at that and then calculate how long that token has remaining of its life, plus 5 seconds for safety. And then I set the TTL on the etcd. So etcd, it's going to remove expired tokens from me, for me, without me doing anything. It does it for me. Does that make sense? And then in the common, verifying a token is in the common package. So I had to add that to the common package. So here in the verify token function, there's a new function, is token revoked, and that's now part of the validation. And I disable it for testing, of course. But if when I verify token, in addition to checking that the signature is valid, I check the token, the revoked token list. And as I mentioned before, I wanted to try this cache idea. So I added this TTL cache, which this is from the package called Cache Tools. It's an open source package. So basically, for 1 minute, I'm not going to repeat a query for a token that I get. If I get it again during that minute, I'm going to use a cached answer if it was revoked or not. And then after that minute, I'm going to ask again. So that's how this works. Now this is going to be the common package version 0.2, and all the services we have so far are on version 0.1. So we can release this, and then we need to do some new deployments. We need to upgrade users and messages to use this so that they can check token revocations. And you can do it at any time. And until you do, you're not going to have, you can deploy this functionality and have the services not use it. That's totally fine, right? That's the whole idea with micro deployments, right? As you have a little piece of a big feature, you just throw it over the fence, deploy it, and it sits there until someone starts using it. So, of course, before we start thinking about upgrading, all those services, we need to deploy this functionality. So we're going to go to tokens and get version 2, build it and deploy it. Oh, that was quick. What a nice surprise. So MF upgrade, I can say roll tokens. And that's going to upgrade tokens to V2. So now we have the functionality, and now we need to bump the common package version in the requirements file for users and messages to 0.2, and then deploy those independently at any time, and then that will basically implement this feature that spans all these services. So in the spirit of saving time, I'm not going to, building these packages take a minute or two each, so I'm not going to do it. But you should do users, send it to version 2, MF upgrade roll users after you build it, and then messages to version, we are on 2, we need to send it to 3. And if you look at the diff in GitHub for these two versions, version 2 of users and 3 of messages, the only change is a change in the requirements. That's it. So this is the final one. So the only thing that we're missing now is the WebSocket portion, right? The socket IO part. And this is the most challenging one because it affects pretty much the whole system. So I'm not going to make it. I have like 10 minutes. Hopefully they don't kick me out if I run a few minutes late. Fingers crossed. So these are, I don't know if you remember from the original app. Socket.io is a protocol that's based on events instead of requests like HTTP. So this can work over WebSocket, or it can work over a long polling. And the Socket.io protocol adapts itself. It finds the best mechanism to do this. If the client supports WebSocket, it'll do that. And if not, it'll go with long polling, which works anywhere. So there are 3 events in the server. There was one that the UI sends to ping users. But basically, this says this user is still active, and that will keep it in that list on the right as an online user. And then when you post a message, the client sends the post message event. And when a client goes away, the Socket.io protocol itself will send a disconnect. And then that's when we are going to mark that user as offline. And that will make it go away from that list on the right. And then, so that's on the server. And then on the other side, Socket.io is bidirectional. So the server can do server push and send stuff to the client. And one that basically updates anything that changes, it's called updated model. And that could have a new user, a new or changed user, or a new or changed message. And then the UI doing JavaScript will know how to get that, whatever it's in the DOM, updated. And this is not the right conference for that, but if you are interested in how I do that, I'm more than happy to tell you. But basically that didn't change from last year. That's the same mechanism. And it's implemented with Backbone, by the way, Backbone.js. Something that I realized that I missed last year, this is a bug in the application. When I was doing all this work, I found this bug. If you post a message and your token has expired, if you post it through Socket.io, the server will receive it. It'll try to validate the token. It'll fail, and then it says, "Okay," and nothing happens. So then the client doesn't find out that it needs a new token. So I added one more message that the server can send to the client, expired token. So if the client sends an expired token, then the server will push a notification to let the client know that it needs to do something to get a new token. And in this implementation, I send the user to the login screen so that it can log in again. Probably in a production app, you will not do that. You will have a mechanism to renew the token. So I didn't know where to begin. There are so many things that you need to change to implement WebSocket in an application that doesn't have it. Especially because now we have all these 4 services, and where do you start? So I made a list. I made 4 lists actually of things that need to change. So of course for the Socket.io service we need to make it right. That one doesn't exist. But that's actually easy because we can copy paste from the old app. But then the common package needs one little piece with the load balancer. The Socket.io service is stateful. So if you have, let's say you have 3 instances of Socket.io on the server, you need to make sure that the load balancer sends the events from one client always to the same instance, because that's the instance that keeps track of that user. So this is a stateful service. Remember I told you this is a big no-no. Well, we have no choice because that's the way things are. I'll tell you how to handle that. But you have to account for that. So HA Proxy as well as Nginx, they all, load balancer have a configuration item where you say, it's called different names, but it's typically called sticky sessions. That means that when repeated requests come from the same client, the load balancer, via some sort of algorithm, it remembers which of the instances received that the first request, and it keeps sending those requests from the same client to the same instance. That's called sticky sessions, the generic name. So HA Proxy supports that. And the container that I'm using that hosts HA Proxy also supports that, but I didn't implement it up until this point. So that needs to be added. So that's going to go in the common package. The UI service, when users come online or offline, it needs to tell the UI, it needs to push a message to say, hey, you need to update the status of this user. This user didn't exist and now it's online, or this user went away. Now you need to remove it from the list. So that's done through the message queue. The user service, it's the only service that knows when a user comes online or offline. So it'll push to the message queue the updated model event, and then the Socket.io service will pick it up from the queue and send it to the client over WebSocket or long polling. So that's users. Messages, same thing. When a new message comes, or when we have this asynchronous message rendering, initially we're going to show the message with the markdown, and then we're going to go in a background thread to go do the scraping of those URLs that might be in the message. When those URLs are back and we have that content, we need to re-render that message in the client. We're doing it in 2 steps because we want to show the message immediately, and then when we have the remaining information, we expand it. So when that happens, once again, it needs to put a message in the message queue. And then the UI needs to know that now it needs to connect via socket IO versus REST, which it did before. So we need to make all those changes. We need to make them in a way that nothing breaks ever, right? So at all times, you're going to have users running this and chatting, and you know to somehow figure out how to do this. So for the socket IO service, it's going to be a very simple service. So it's going to have only socket IO events. It's not going to have any REST and any HTTP endpoints. It doesn't have anything like that. It's so far removed from HTTP that at some point I consider I don't even need Flask for this. Right? You don't really. Except that Flask has a user session, and my so the Socket IO, there are two packages for Socket IO, both are mine. There's a framework agnostic package called Python Socket IO that works for any framework. And then I created a Flask Socket IO package on top that adds some niceties and makes it look a little bit more friendly to, if you're using Flask. And one of the things that I added in the Flask package is support for the user session in the Socket IO events. So I decided to stick with Flask just for that reason. I wanted to have access to the user session. So I decided to basically keep Flask, but still I wanted to go async. And the reason that this needs to be an asynchronous service is that each WebSocket connection will take one worker, one dedicated worker. It's a long-term connection, unlike HTTP where you connect, do the thing, and then the connection breaks. So this is going to stay on for as long as the client is connected. So if you have one worker, you can take only one client, unless you go async, in which case you can have thousands, basically. So if you want to understand why all this logic of going async when we're using WebSocket, I'm doing a talk on Sunday about this. So you're invited to that. But basically, you have kind of no choice when you're working with this type of WebSocket or long polling, this long-term connection type stuff. So now you need to start thinking, how to coordinate, right? So we know that the Socket IO service will have to send mark users as online or offline, right, as they connect or disconnect. Now the Socket IO service will be the one that knows when a socket, when a client comes online or offline. That's the service that will receive the notifications. So we need to add endpoints in the user service to basically mark a user as online or offline. So two new requests. So we're going to use put and delete on this /me endpoint. So put will set the user online, and delete will set it offline. And then Socket IO will send these requests to, when it gets the notification, it'll internally talk to users to update the user state. So the Socket IO service, let's take a look. It's actually fairly simple. So once again, there's an app.py, and it's actually very short. It's all copy pasted. So we have the three. So we have ping user, post message, and disconnect. So disconnect is triggered automatically by the Socket IO server. So for these two, the client will initiate, right? It'll send the event and it'll pass a token, right? It has the token, so it'll send it. Now for disconnect, we don't have disconnect basically comes from the framework itself, so we're not going to get any arguments. I still needed a token because I need to send a request to users, right, to mark the user offline. So this is the reason why the user session in Flask was useful. Anytime I get a token in any of these two client-initiated events, I save the token in the user session. And that's how, when I get a disconnect, I have the token to mark the user offline. And that's the only reason why, in this case, I decided to go with Flask. if I wanted to implement the user session on my own, I could have gone with async IO, whatever. It doesn't really matter. So we can go ahead and deploy this socket IO. So once you have the socket IO service ready, you can just throw it over the fence and deploy it. Nobody will use it yet, but you can deploy it. So I think this should be built. Yeah. So mfrun. So mfrun I use for the first time, right? mf upgrade is when you already have it. So mfrun socket IO, and that's going to run. Nobody will use it yet. So the way you coordinate, so you want to make sure that this new service is not used until all the parts, in other services are implemented. So you want to make sure that users is able to push updates to the message queue, and you want to make sure messages is also able to push to the message queue. Once you have those two pieces, then you can say, okay, I'm going to update the UI to connect via socket IO. So we need to upgrade these three services, right? They all have parts of this feature, but you need to, we need to find the correct order to deploy these so that the application always runs, right? So usually you're going to be deploying, pretty common to deploy features in dark mode, right? They're going to be there, but nobody will be using them. So we're going to have users, it's going to be pushing changes to socket IO, but there's not going to be any socket IO clients to listen to them yet, right? But that's the correct way, right? If you deploy the UI first, then you're going to be missing notifications. You're going to make sure that the notifications are in place before you start using socket IO, right? So you have to think very carefully about the order and test it on a staging server. Make sure that really things don't go down while you do the upgrades. So basically, that's the. I think this is a very good example of how to carefully think about how to deploy, complex updates that require, multiple services. The opposite of this, which I've seen, and it's really awful, is when if you have, these three services that, or actually four, just shut everything down, upgrade everything, and then everything back up. But you have downtime, right? So, not good. This is, in my opinion, this is better. You can still reserve the option to use downtime where you have something really complicated. But this is more exciting for me. Think about doing this in terms of keeping everything going, right? Like the big guys do, right? They really, sometimes they go down, right? But it's actually when they never expect it, not when they do an upgrade. So I'm going to let you do these upgrades on your VMs at your own time. There's really, if you do it in this order, then you're going to have the end product. After you do this, you're going to have the one that you get when you deploy the VM for the first time. And this completes the project. So I'm 8 minutes late already. So very quickly, I wanted to tell you that even though I went with a homegrown solution for deploying this, which is totally valid. I will use it myself. I really like it because of its simplicity. It's totally fine. You could take this application and deploy it on Kubernetes, for example. And I was wondering if it would be easy or not to do it. And I went and created all the scripts to do it, and I didn't have to change a single line of code. So if you go on the admin repository, install/Kubernetes, you have all the scripts, and you can deploy this on a Kubernetes cluster. Things that you get for free when you use Kubernetes, secrets are not handled through the environment. Kubernetes has a subsystem for storing secrets, and I'm using it in these scripts, handle secrets the correct way as far as Kubernetes go. And then the way you register services on the load balancer is simplified because Kubernetes gives you a DNS name for each service. So, for example, HTTP users, it's going to be the load balanced user service. So, you always talk to users on that URL. So, and then you do the scaling through the Kubernetes code is replicas. So you can set the replica count on each service, and that will create more instances instead of using the mfrun homegrown thing that I was using. But the containers are all totally compatible. I didn't need to change anything because inside the container there's no assumptions made. Okay. So another option that you may have is to go with the container service in AWS. Right. This is actually the same as having a Docker running on a VM. So no problem there. As a benefit, you have access to all the services in AWS if you like that. So instead of using Redis for the message queue, you could use SQS. You can start migrating to you can start RDS database if you want instead of deploying your own MySQL. So you have all those options, and they're going to be nicely integrated with the service. But once again, the code is completely independent because all the configuration goes through environment variables. So and of course, if you've used AWS, it's a headache to set up roles and stuff. So that's of course we don't have that on this little solution that I built, with Bash scripts. But when you deploy to AWS, you're gonna have to have security, in mind, and you have to set up your security groups accordingly. You can go serverless. This is another option. So this is what I do at work. So I have some experience with using Lambda and API gateway. It's a completely different paradigm. The idea is that not that there's no server, but that you don't have to run a server, right? You push the code to AWS Lambda and then configure your endpoints in API gateway, and then AWS runs a server for you. And it does it how it sees fit. So it will start a server when there's some traffic. If you get a lot of traffic, suddenly it'll start more instances. So auto scales, all automatic. You don't have to create a load balancer. You don't have to create a service registry, nothing, right? AWS will do it for you. And it'll charge you per usage. So each request gets you have to pay for each request. So it's really nice, but yeah, it's very different. In particular for Whiskey applications, we're used to writing servers, right, in Whiskey. And here you need to write a function that AWS can call. There's no server. So GUnicorn doesn't apply, for example, or uWhiskey, none of that. You just need to provide the code. Now, if you know how Whiskey is implemented, Whiskey is a callable, right? It's a function that you call. So there are tools that convert a Whiskey server into a function. And the most popular one is called Zappa. It's open source. It's pretty good. I also made an attempt to a tool of this kind that's called Slam that basically does the same thing, but it does it in a slightly different way to Zappa. So you're welcome to try both and see which one you like best. And then one of the problems I see, since you have no server, there's no way to establish long-term connections. So WebSocket is a no-go. You can't have a server running for a long time because you pay for the time that your function runs. So if it runs forever, all the functions have a timeout. So it's not going to run forever. So there's no way to keep a connection alive for a long time. So in this case, if I had to do this with Lambda, I will deploy the 4 services that are not WebSocket as Lambda services, and then I will deploy the only WebSocket service, in an EC2 or ECS container. The other thing that I noticed, it's a constant pain for us. It's that compared to something that you deploy normally, serverless is slow. So all the requests going through API gateway and then into the Lambda, AWS needs to start a server when you don't have constant traffic. So all those things add up, and the response times are not that great. They're not awful either. It's something that you can work with, but it's a little bit slower than what you would like most times. Finally, another thing that you can do is if you don't like any of this Docker nonsense, right? You can just deploy processes, and that's totally fine. All the stuff that I did today can be deployed as a regular process the old way, and it's totally fine. So etcd, HAProxy, confd, MySQL, Redis. So all those base services, they can run as a regular process. They don't have to run under Docker. You're going to have trouble scaling them, right? Because then you're going to have to assign ports, right? Now you're running in a host, and you have to manage which ports you assign to which services. In particular, for your own, the application services, you're going to have to, if you want to scale up, you're going to have to find an empty, an available port to run the new instance. And then, that's Docker does that for us. So it's really nice. So I created, you don't have to read all this right now, we don't have time, but I created a long list of ideas to improve the system if you want to play with it and, get more used to this idea of running microservices. There's a bunch of things all over the place that you can attempt. So going from improving the token service to, having a highly available databases. Somewhere in there, I don't think I mentioned this. Now that we've lost the ability to do joins in a relational database, using a relational database, it's not really that useful compared to going NoSQL. If you've seen my talks, I really like relational, right? I'm old school, I like relational, but if you don't have your joins, what's the point, right? So, one of the assignments here is, you could go try either Mongo, or if you're on AWS, you can try Dynamo, one of those. So anyway, Chaos Monkey is another thing that could be interesting. Now that you have this, you can write a script that randomly kills services and then enjoy when you see that the thing doesn't go down. So a number of things you can try. They're very ordered from easy to insanely complex, I guess. So this is the order. So anyway, okay. It's late, but I'm sorry. So I'm done. I'm going to take questions if they let me. And once again, that's the link for you to